Imagine being stuck in a tin can, hurtling through the cold vacuum of space for years on end. The physical and mental tolls of long-duration space missions are not for the faint of heart. Join us as we explore the incredible challenges faced by astronauts on their journeys to the final frontier. Space stations provide the capability to support long-duration human spaceflights and the research needed to study the effects of extended periods of weightlessness on humans. The results of the investigations will inform future human exploration missions. Prior to space stations, the longest flight lasted only 18 days, although at the time, 1970, it set an endurance record. The small size of the spacecraft not only precluded a longer stay due to a lack of storage for consumables, but also limited any significant medical monitoring or countermeasures equipment. Some very longest duration missions. Beginning with the first experimental space station, Salyut in 1971, a series of Soviet and American platforms through the 1970s and 1980s played host to numerous long-duration missions, many setting ever-increasing endurance records of up to 237 days. Beginning in 1986, the Soviet then Russian space station Mir hosted numerous long-duration missions during its 15 years of operation, extending the human spaceflight endurance record to 438 days, completed by cosmonaut Valery V. Polyakov in March 1995. His 14-month spaceflight, long enough for a round-trip journey to Mars, remains the longest single space mission to date. Between October 1994 and March 1995, Mir hosted the first long-duration flight by a woman, cosmonaut Yelena V. Kondakova. Challenges that are faced by humans due to long-duration missions. Researchers don't know every possible issue that astronauts will encounter during an extended stay in lunar orbit, a round-trip flight to Mars, or a journey to Jupiter's icy moon Europa. But space medicine researchers are taking the data they do have from analog long-term missions carried out on the ISS and human isolation experiments carried out on Earth, as well as animal studies, to prepare astronauts for what breaking the bonds of Earth will do to both their bodies and minds. Here are just a few problems experts are considering to keep astronauts happy and healthy on their way to the Moon, Mars, and beyond. Spaceflight-associated neuroocular syndrome, SANS. On Earth, our bodies are constantly fighting gravity to pump fluids up to our heads. However, when you take gravity out of the equation, you get all pumps and no dump. The cranial fluid doesn't fully drain. The result is fluid pooling in both the face and the skull. This is known as spaceflight-associated neuroocular syndrome, or SANS for short. Puffiness in the face during the first few days of the mission quickly resolves itself as the body acclimates to microgravity. But for the cerebrospinal fluid that surrounds the brain, things don't normalize as fast. Radiation risks. Here on terra firma, we're protected from cosmic radiation by Earth's magnetic shield, which includes the Van Allen belts. Outside this zone, however, highly charged particles streaming from the sun or beyond can slice through the bodies of astronauts, damaging cells. This causes a whole host of issues, such as radiation sickness and increased lifetime risk of cancer. Right now, we mitigate the risk of radiation by shielding spacecraft and closely monitoring radiation exposure. But research also suggests that cosmic radiation during a Mars trip might cause more immediate issues. Radiation damage to tissue may affect astronauts' behavior, cognition, and general health while on the Moon or Mars, so it's vital to shield a lunar or Martian crew from as much of it as possible. Hazards to the microbiome. Many aspects of our health, from good digestion to stable mood to healthy skin, are maintained by our microbiome, the complex cultures of bacteria, fungi, protozoa, and viruses that live on and inside us. In space, however, the balance of these tiny helpers changes from what you'd expect on Earth. Studies following astronauts who have recently stayed on the ISS show that microbial diversity in the gut increases upon return to Earth, whereas in other areas of the body, such as the nose, it decreases. Maintaining crew cohesion. Like any long-haul journey, an extended trip to the Moon, Mars, or beyond will be a lot more bearable if the crew members get along. And part of ensuring travel harmony is a good crew selection process. Assembling a cohesive crew isn't just a case of cherry-picking excellent astronauts. It requires considering the group's dynamic as a whole. And to study the complex nature of isolated groups, researchers often turn to analog missions or simulations of living on the Moon or Mars that are hosted elsewhere, like on Earth. By utilizing both analog missions and extensive social sciences research, space agencies across the world have honed their own unique, highly secretive methods for selecting the right astronaut crews. Cardiology. In deep space, the microgravity environment induces similar cardiovascular effects to what astronauts experience in LEO. Blood and bodily fluids shift toward the upper torso and head, resulting in puffy face and bird leg syndrome, while the decreased cardiac workload can lead to cardiovascular deconditioning. However, relative to the gravitational force in LEO of approximately 0.95 grams, the Moon's gravitational force is 0.16 grams, while Mars' gravitational force is 0.36 grams. Stress. Finally, the mental stresses of being in space can pose a risk to human health and safety. The disconnect from loved ones on Earth and the cramped nature of spacecraft can cause anxiety for astronauts. Astronauts also generally report about 2 hours less sleep when in space than when on the ground. This can contribute to feelings of stress. Space sickness. On the ISS, or spacecraft that has flown into space, the force of gravity is much weaker than on the Earth. As a result, many people show symptoms of space sickness, such as headaches, nausea, and vomiting. When we are on the Earth, we are strongly affected by the force of gravity. We have a small organ called the vestibular organ deep inside our ears, in the inner ear, that plays a key role in keeping our bodies balanced. In the low gravity of space, the information received from the vestibular organs changes. This is thought to confuse the brain, leading to space sickness. But this condition does not continue for very long. If you stay for a few days in space, your brain adjusts its interpretation of the vestibular information, so the space sickness goes away. There are individual differences in the severity of space sickness, and some people don't experience it at all. When you return to Earth, you experience the effects of Earth's gravity again, and thus gravity sickness sometimes occurs, with similar symptoms as space sickness. As we set our sights on exploring the far reaches of our solar system and beyond, it is imperative that we confront the challenges of long-duration space missions head-on. From mitigating the physical and psychological effects of isolation and confinement to developing more sustainable and efficient life support systems, we have a long way to go. But as we continue to push the boundaries of human exploration, we must also remember the importance of international cooperation and collaboration in achieving our shared goals. Don't forget to subscribe to our channel, or you will miss out on our space-related videos.